The first equation is not in slope-intercept form, but it can very easily be changed into slope-intercept form if we were to bring that 2x to the right-hand side and rewrite that as y equals negative 2x plus 4. Doing that, we would see our y-intercept of 4, and we'd see a slope of negative 2, which would tell us to go down 2 and over 1 in order to draw this line. The second equation is not in slope-intercept form, it's in standard form, and usually when my lines are in standard form, I prefer to graph using the intercept method. When I let x be 0, substituting that in, I have nothing basically out front here. The 4x turns into 0. I can cover that over with my finger and see negative 2y equals negative 4. Dividing each side by negative 2 gives me y equals 2. So 0, 2 ends up being our y-intercept. Likewise, we can let y be 0. Substituting that in makes this 2y term disappear, and all we have to look at is the 4x equals negative 4, and dividing each side by 4 gives us negative 1 for x. So negative 1 comma 0 is our x-intercept, which we can draw now. And now we have enough information to draw this second line here. And it appears that our point of intersection is at the point 1/2, comma 3. Now that is if my graphing is accurate enough. For all we know, that's not really a half. It might be 2/5 or 3/5 or some messier fraction. But we can check this very easily by substituting x and seeing if we get the resulting y. When we substitute in a half for x here, 2 times a half is 1, plus 3, 1 plus 3 equals 4. It works in the first equation. And substituting half in for 4, or for an x here, 4 times a half is 2. 2 times 3 makes 6. 2 minus 6 then makes negative 4. It works in the second equation. And if you can take this point, which you think is the solution, and substitute it into each of your given equations and find that it satisfies them, you know for a fact that you have graphed this correctly and that negative 2, or negative 1/2, comma 3 is your solution. This next problem asks us to determine whether these points here are solutions to line 1, line 2, both or neither. So we start with the point 4, 5. Letting x be 4, we have 2 times 4 is 8. 8 minus 17 is negative 9, which is not the same as 5. So really, line 1 is not going to work there. We try 4, 5. In the second line, 13 times 4 is 52, 6 times 5 is 30, and 52 and 30 are not going to make 23, so I can see that this is going to be a solution of neither. 4, 5 works in neither of those lines. Let's try 6 comma negative 5. Substituting 6 in for x gives us 2 times 6 is 12. And 12 minus 17 does give us negative 5. So right now, line 1 seems to be working. Let's see if this point works in line 2. 13 times 6 is 78. 6 times negative 5 is negative 30. And 78 minus 30 does not make 72. That does not work there. So line 1 is the only one of those two lines for which 6, negative 5 works. Let's try 5, negative 7. In the first equation, we get 2 times 5, which is 10, minus 17 does make negative 7. It works in the first line. Now, let's take 5. 13 times 5 is 65. 6 times negative 7 is negative 42. 65 minus 42 does make 23. So, ding, 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 we have a solution working in both equations. The point 5, negative 7 is a solution to both of those lines. Therefore, it's a solution to that system.